All right, so what we're talking about here is something called direct evaluation of a limit. And what it is given a limit problem, you're going to take the value that x is approaching, and you're going to simply plug it directly into the function, and your goal is to then see what comes out. So direct evaluation is just plugging the x value into the function. So we can look at a quick example, something like a limit as x approaches 2 for a function x squared plus 2x minus 3. So what we do is we take the value that x is approaching, in this case it's 2, and we simply plug it into our polynomial here. So we're going to take 2 and square it, plus 2 times 2 minus 3. So this gives us 4 plus 4 minus 3, and that's going to give us a value of 8 minus 3, which is 5. So what this says then is the limit as x approaches 2 for the function x squared plus 2x minus 3 is equal to 5. The way that we found that is by direct evaluation. We just took the value that x is approaching, plugged it into the function, and got out the y value 5. So as x gets really close to 5, the y value, or sorry, as x gets really close to 2, our y values get really close to 5. There are a couple of results that come from direct evaluation besides a real number. So the next little part here is results. So the first result is what we saw, and that's where you get out a real number. So the nice thing with continuous functions is that direct evaluation will always work. So just remember that if you have a continuous function, then direct evaluation will always work. So simply take the functions, or take the x value that the function's approaching, plug it in, you're going to get out a real number. That means that your function was continuous at that point and it exists. So if you get a real number, you're done. Okay, the next result is a little bit different. This is where we get a real number. But that real number, maybe we had a quotient function and it's divided by 0. So if your limit results in a real number divided by 0, this typically means that your function's limit does not exist. Okay, so if your function's limit does not exist, that means it's more than likely approaching a non-removable discontinuity. So this is something like a gap, a finite gap in the graph, or potentially a vertical asymptote. So if you're approaching something like that, then your direct evaluation is going to tell you that your limit does not exist, and that's where you have a real number divided by 0. The last option here is whenever we get something like 0 divided by 0 or infinity divided by infinity. These are called indeterminate forms. And indeterminate forms means that the function's limit cannot be determined by direct evaluation. So by simply plugging the x value into the function, we're going to get something that we're not able to evaluate. So 0 over 0 or infinity over infinity. And so what you have to do is maybe try a different form of evaluating the limit that we'll talk about later, something like factoring. You might use the conjugate. Or something that's really nice, after we start talking about things called derivatives, we can apply this nice method called L'Hopital's rule, and we'll talk about that much later in class. So that's it for direct evaluation. All you're doing is taking the value that x is approaching, plugging into the function, and seeing what comes out. If you have a real number that comes out, that means that your function's limit exists. If you get a real number divided by 0, that means that more than likely your limit is not going to exist because you're approaching a vertical asymptote or another jump discontinuity or a non-removable discontinuity. If you get an indeterminate form, more than likely your limit is going to exist, but you need to find that limit by factoring, using the conjugate, or applying L'Hopital's rule.